Hello Professor, this is Sarthak and with me I have Ashka Gandhi, Michelle and Pratham Sethi. Together we have worked on the cybersecurity domain and we have used machine learning techniques to evaluate the dataset. Here I would be taking you over through the workings in the Python Jupyter notebook, and the presentation as well as the explanation would be later explained by my colleague Pratham Sethi. So to start with, I imported the NumPy and Pandas library to help us work in the arrays as well as the data frames. Then we imported our dataset and named it as DF. Here we saw that dataset has 1 lakh records over 35 columns, or the 34 features and one target variable. In the df.info we see that most of the columns have integer data types except the hash as well as classification, which have string data types. When I explored into it further, we saw that df hash, or the hash column in particular, has 1000 it is spread over 100 unique values and 1000 records. So to get a better assessment of the model, over here I used the label encoder function, where we got the numbers rather than the string for a further model analysis. I use the df.describe function to help us get the value for counts, mean, standard deviation, minimum value, maximum value, as well as the quartiles or the percentiles. Here, as we can see, that many records have 0, mean, median, minimum, and maximum value, and these will not help us in contributing in the model, and thus these were removed further. Over here, I have removed all these columns which had 0 values, and from here our data cleansing process started. Then later on I removed some duplicate entries so that there is no biasness, and finally I checked for any errors in our data and found that there were no missing values. Later on I used the mapping function to classify our target variable into 0 or 1, where 0 represents malware class and 1 represents benign class. Here I used df classification.unique so that we could confirm that 0 and 1 were the two unique values that were found in a target variable. Next, I started on the instances for each classification, and I saw that both the classes in our classification, benign and malware, had 50,000 records each. I tried to visualize the correlation, and over here as well as on the heat map over here, I found that our classification has highest correlation with hash, as we see over here, since the number is in red or close to 1, although the other features have slightly lower correlation or the negative correlation. Now we started with the machine learning algorithm to test the predictability on the model. I initially defined variable x, where I removed the classification column from our data, and I used the classification column and instantiated it as y. Then I imported the standard scalar function, and through standard scalar I scaled all the values for the x variable. The reason for this was since the mean, median, minimum and maximum values for all the variables were very different. So to be in same line, I have scaled them everything by using the standard scalar function. When I move on ahead, I imported the logistic regression and instantiated it with the name LR. Later, I segregated the data by using the train test split function, where data was segregated in a proportion of 0.8 to 0.2, that is 80% of the data was our training data and 20% was our test data. Now, to test the model fitness or the line of test fit, I used lr.fit function and I fitted this on the training data, and later on I predicted the values for the X test. To compare how our actual versus expected values perform, I used the score function and found out that the score was perfect 1, meaning that the model was largely accurate. I further evaluated that the mean absolute error, mean squared error and root mean squared error, these were all 0, so that again contributes to the good predictability of the model. Over here I found that precision as well as recall score and F score was 1, again indicating that the model has perfect accuracy. In the support vector machine, moving on, which was our second classification model, which works on the hinged line rather than the log loss line as in the logistic model. Here I again did the similar process and I instantiated a model support vector classification, renamed it with the SVMs. Here random state equal to 100 defines our seed, and I use the training data to fit the model, and then finally predicted method, and I came up with a confusion matrix and classification report. Here we see that true positives has been 9972 and true negatives has been 10028. False positives and false negatives have been 0, which again predicts to the correct accuracy of 1. Whenever we move further over here, we see that even from this particular model, the accuracy has been 1, and we try to plot the graph for the same to make it more visualization. From over here in the decision tree coefficient, here I used another model in which we have used decision tree classifier, which works relatively on the classification, as in it works on the nodes, roots, and goes a step-by-step classification. Even here we have seen that the true positive and true negative bits have been completely accurate and with 0 values of the false positive and false negative, indicating a perfect accuracy of 1. I even try to compare decision tree using the Gini coefficient as well as the entropy coefficient, since they evaluate these are the measures of the impurity, and there was no difference in the accuracy score. I further used random forest over here, since random forest is said to be even a more accurate or advanced version of the decision trees, but since our accuracy was 1 even in the decision tree, I was expecting it to be 1 over here, and so was the result. In the end, I used cross validation score. As we know, in the cross validation score, which is a replacement of train test plate, the model is tested using 10 different samples, or the 5 different samples, which are depending on the number that we use. Here we got these 5 numbers and the average CV4 for each number for each method. Finally, we use the voting classifier to see how different logistic regression, decision tree classification as well as the SVC models behave, and in the end how they vote out on the perfect score. And as the score for each model obtained was 1, we got the voting classifier equal to 1. That's it from my side. My colleague Pratham would be taking you over the detailed explanation in the next part. Thank you.
Thank you, Sarthak. And now I'll take you through the report. The objective of this assignment is to pre-process the data provided and pre-process it for training 3 ML classifiers. Then we will test these classifiers and assess the results thereof. Now I'll give you a brief overview of the dataset provided. The dataset provided composes of cybersecurity in a CSV file format. The file contains 100,000 instances and 35 different features. Most of the features are integer format and 2 features are in object. Features that will be classified are composed of malware and benign. The total number of instances have been equally amongst malware and benign. That is, 50,000 instances are malware, 50,000 instances are benign. Now let's look at the correlation between these. On the right, you can see a heat map that shows the correlation between the dataset variables. There are several variables that have a very strong positive correlation and others which have very strong negative correlation. This will be useful in the classifier models that are being built and tested. As my friend Sarthak explained, cleaning and pre-processing, the data was scaled and transformed. It was split into balanced test and training sets. The model was trained using 20% test size. The data was divided into the ratio of 20% 8 train. While calculating the results, it was produced that there are no false positives or false negatives in the dataset. The precision, recall, and F1 scores are all strong, indicating that the model is very successful at classifying the instances based on the features. This can be seen on the image on the right. As you can see that There are no false negative or false positive instances. Further, you can see that the model is very accurate at 100%. The precision, recall, and FR scores are all perfect. Next, we'll move to the M classifier. Similar to the logistic regression model, the SVM shows similar results, that is, no false negatives or false positives. The true negative and true positive ratio remains the same. The precision, recall, and F1 scores were all perfect, and F1 score was also 100%. This means that our model is successful at classifying the instances based on each features. The next machine learning classifier we tried was random forest, and you would be amazed to see that similar to the previous two models, the random forest model performance was calculated again, no false positives and no false negatives, showing the same split between true negatives and true positives. The precision, recall, and F1 scores were perfect, the accuracy of 100%. Now let's move on to the conclusion. As seen in the, we have masked both the dependent variables, that is malware or benign, as 0 and 1 respectively. The three machine learning classifier models used for this project were logistic regression, support vector machines, better known as SVM, and random forest. As can be seen on the right, the results of the three models were identical. Further, it may also be noted that none of the models produced any false positive or false negative results. It was just true positives and true negatives in the same proportion for all the three models. To provide a steady conclusion, we can say that though the performance of the models was excellent, it could be suggested that the models were overfitted, generating the same results above. Thank you for this opportunity, and now we can have some snapshots of the Jupyter Notebook code that was used and explained by my friend Sarthak. We thank you for the presentation. Thank you.